Victoria Jeffrey and Hannah Maddy from Chef. Please give a huge round of applause for the ladies.
Hi, everyone. How's everybody doing today? Woo! Okay.
Good.
Well, welcome to Mario Star Power Your Infrastructure with InSpec. Thank you for being here today. My name is Hannah Maddy. I work on UX here at Chef. I've been focusing on compliance for the last year or so.
And I'm Victoria. I'm an engineer here. I'm an engineer at Chef, and I've been working on compliance and InSpec-related topics for the last year.
So, Victoria, what is this whole InSpec thing?
Okay, so I know a lot of you have already heard a lot about InSpec. Nathan mentioned it in his wonderful talk yesterday, and many of you came over to the booth to ask about it. Basically, InSpec is a testing framework. It allows you to ask questions of the state of your systems. So anything that you're configuring onto your systems, you're going to want to go ahead and test, right? We always want to test our assumptions. So InSpec allows you to do that by just going in and asking the system, hey, what is the state of this one specific requirement?
And the really cool thing is that InSpec is completely free and open source. There's 4 different ways you can install InSpec. You can install it via the Chef DK, the Chef client, or you can do a gem install InSpec, or you can download the InSpec package off of our inspec.io website or our downloads.chef.io. You can also pull the Docker image, InSpec Docker image. It's Docker pull chef/InSpec, which is readily maintained by our crew as well. So, what's the difference between InSpec, ChefSpec, Test Infra?
Right. So a lot of you are already actually using many of these frameworks. I spoke to some people yesterday who are using ChefSpec already. I spoke to some people who are using ServerSpec. These are awesome frameworks. ChefSpec is awesome for testing, kind of unit testing all of your configurations, right? Test Infra is a great way to test things. Unfortunately, Windows support is not all the way there. ServerSpec, InSpec was actually built on many of the learnings from ServerSpec, so it took a lot of what ServerSpec was already doing and just kind of beefed it up, gave it a little bit more.
And as you may know, ServerSpec is based off of RSpec and written in clear Ruby. InSpec consists of human-readable metadata, so it's easier to communicate and share the tests that you written with your friends and your coworkers. It also includes a large library of resources and the ability to write your own resources, which we'll go over a little bit later here. So in general, it just offers a streamlined way for testing, and we'll go ahead and show you how.
So InSpec actually allows you to test your nodes over SSH, WinRM, and Docker transports. This means that you can connect to anything that will allow you to connect via SSH, WinRM, and Docker, and without actually modifying that node itself. It will just connect in, run the commands it needs to do, and then come back and tell you about it.
So whether you're using Chef, Ansible, Puppet for configuration management, you can still use InSpec, as you don't have to install anything to your target system, meaning that you don't have to alter the state of any of your systems. I pushed that slide for her, so you get to see this animation of
and this
work.
This is actually showing us a little bit about Train. Train is actually the back-end part of InSpec. So Train is the one that's going ahead and connecting up, if any of you have used it outside of that, and connecting up to the node and allowing InSpec to go in and run the commands it needs to run. So,
y'all ready for a demo?
We're going to show you some InSpec. Okay, so we're going to start over here, and let me know if that needs to be bigger, but I think we're okay. All right. So the greatest thing about InSpec, we're going to first start with just, it's a gem install, right? So I'm not going to gem install it. I already have it installed on my machine, but you would generally just do a gem install InSpec, and then you could have it right there. So to check that I have InSpec going, I can run InSpec, and it's going to tell me about a bunch of different nice little commands I can run with InSpec. So let me just check my InSpec version. And I've got InSpec there. I'm all set. Okay, great. First thing we're going to do is inspect detect. So if we come back up here to the commands, we're going to see that it told us inspect detect is going to tell us about, I'm sure you can't quite see it because of sizing here, but inspect detect is going to tell us about our system. So if I inspect detect just locally, we're going to see that it's telling me I've got a Mac OS. That is true. You can see it. I can also run this against some different machines. So before we came up here, I started up 3 different little VMs and containers, right? I got one with WinRM, one with SSH, and one with Docker. So if I actually come up here, I can go ahead and say, hey, I want to go connect over to my WinRM machine, and I want to find out about my WinRM machine. I want to ensure that my connection was actually made and that I'm connecting to the thing I think I'm connecting to, right? So now it's going to go ahead and tell me Windows. I can run the same thing with my SSH. And as you can see here, all I'm doing is an inspect detect with the T for transport, and then I'm telling it how to connect, SSH, WinRM. I'm giving it all the information for the node, the password, the port, whatever I need to connect to it. I can do the same thing with my little Docker container I have up, and just Docker CCPG, and it goes ahead and tells me about all that. So that's great, right? Because now I found out about my system. Now here's the really nice icing on the cake with InSpec. InSpec has this concept of the inspect shell.
So the inspect shell is a pry-based read, eval, print loop that allows you to test pretty much validate any of the tests that you've written right directly in the command line before you construct it into a file. It's a great way to validate that your tests are working properly. You've written any, didn't screw it up, and so go ahead and demo the shell.
Yeah, so the inspect shell, as I logged in, right, all I did was do that same inspect detect command that I had before, except I replaced the word detect with shell. So now I'm actually connected into that node, and like Hannah was saying, it's a read eval print loop, right? So I'm just going to be able to come in here and run any commands or any tests that I thought, like that I wanted to run with my inspect tests, and confirm right now, right here, that this works. So it takes away that step of saying, hey, I want to go run this, and then come back and get that loop. The feedback loop just becomes smaller and quicker, which is really useful, right? So when I'm in the inspect shell, I can go ahead and do help, and it's going to tell me about a couple things. The best thing here is help resources. Hannah mentioned earlier that there's a whole list of resources that are already available to you in InSpec, right? So if I do a help resources here, I'm going to get a nice big list.
Boom, check that out.
Yeah. So now I'm going to go ahead and just ask about the SSH deconfig, because that's a pretty common one. We can all relate. So if I help SSH deconfig, it's going to tell me what that resource is actually doing with a nice little description, and then it's going to give me an example. So from here, I can actually find out more about the machine in this moment, right? So if I want to say, hey, find out what my protocol is, SSH deconfig protocol, it's going to go ahead and answer me, right? If I want to find out about the port, and if I want to find out about the params, can't remember. All right, I wasn't sure if that was capitalized or not. And here I've got all my SSH deconfig params, so I can find out right now what's going on my machine. And this allows me to write my test in an easier way. So now I can actually grab, because what InSpec does is run these tests in real time. I can actually grab this example test and just paste it all in here. I could write any test I wanted in here, and it's going to run it and let me know the response. That's really useful when you're writing these tests in real time. I can even show you that if I exit out of here, and let's say I decide, you know what, I don't actually work with Windows often. I got that Windows machine up earlier today, right? But I'm a dev, so I don't play around with Windows. So I don't really know what I need to test on my Windows node, but somebody told me to bring one up. I got to figure out if it's doing well or what. So here I can come over into my into the inspect shell on my Windows node, which we saw just a second ago that it did connect in, because it went ahead and told me that OS platform and family, so I knew I was connected into the right thing. And then here, I don't really know Windows, but I can grab Windows Task, because that sounds like something good. So if I help Windows Task, that's when things really get nice, is if you don't know about the resource, if you don't know about the machine you're on, this is how you're going to find out more little bits of information. So even if I don't know anything about running Windows and what I need to do, I can still find out what tests are available for a specific resource, or at least get some examples to get me started.
So this is a great example of writing your first tests. So InSpec has this concept of a profile and a control. So within a control, you can have one test, you could 2 tests, 3 tests, 4 tests, and Victoria will show you kind of the code structure there. And then you have a YAML file, which that's the metadata for your profile. In the metadata of your profile, this is where you would specify the name for your profile, the description, the copyright information, versioning, also supports. So basically, the supports would allow you to specify the target operating system for your profile. And then you have the controls directory. That's where the controls and your tests would be living in a Ruby file. And then you have the libraries directory, and this is where your attributes and your custom resources will be. And we'll show you that a little bit later as well.
Right, so to get that profile started up, all I did was do the inspec init, a profile, and then I gave it a name, right? So inside of my repo that I'm in, it created this nice new little profile. And now, like Hannah said, we've got that inspec YAML, the controls, and the libraries all right here. So when we ran that test earlier in the shell, that was great, right? We got a lot of information. We already know the result of the test, and we're settled in that way. But inspec also has this concept of a control. So what a control allows you to do is it's a bit of a wrapper around that test. So you're still going to have that test. That test is still the important part. It's the part that's being run. But the control allows you to give metadata information to share more information about the test and the purpose of the test with everybody in your organization in a superhuman readable way. Most of you can probably already read this test. It's not very hard, right? Describe file temp, it should be directed. It's cool. Like we can read any of these tests. It's not too hard. But in case we can't, we can include a title, and to be nice to our friends, we can include a description. We can say why we need to have this test here. But the really nice part about this control is that you can also add something called the impact. So you'll see here I have an impact of 0.7. This is a nice way to share across your organization just how important this test is. So normally if I had a test, I could totally just write right above my test, right? I could come in here and I could be like, hey, yo, this is like, hey, yo, this is really important. And maybe somebody will see that comment, and maybe somebody won't, and they'll probably ignore it. But what the impact does is it allows you to standardize how important those are, and then use that number later on when you're consuming the results from the inspect tests. So in general, we've done impact 0 to 03 is going to be minor, 0 to 04, 04 to 07 is major, 07 to 1 is critical. So you can decide which tests are the ones that are really going to bomb out and tell you, hey, you have got to stop and fix this now.
And some of the workflow would be like adding, so beyond the title and description, you can add references, right? So you can add links to, references for remediation, for example, or maybe some kind of documentation. You can add tags as well. So basically, you can tag that control. A good workflow for that would be like if you have like a control family group, right, for like, the access control. So you have like an access control family group. So you can tag that with AC, and then you can call the control ID, which is a TAMP 1.0, with the AC, 1-1, and construct the profile out of it. You kind of get yourself a little organized.
So from here, what's great is we can actually check that profile, right? So in here, I added a little bit, and we always want to check our profiles before we go ahead and run them because, again, we want a shorter feedback loop. We want to get that information quickly. We don't want to wait to run that profile against that node and then for it to tell us, hey, that profile wasn't right. So inspect has this command called inspect check. And inspect check is going to tell us that we need to put in a path. So if I do an inspect check on that profile that we had just created, which is my first profile, it's going to go ahead and tell me, hey, you kind of messed up. Because do you know what I did? While Hannah was talking, I added this little bit into my control that said tags with a whole bunch of S's because I was busy and I wasn't paying attention. And then the tags up there, not quite right. So if we scroll up here through that nice little stack trace, we can get this undefined method tags. And if we come over here, it's actually going to tell us that we probably wanted to just write tags. So if I go ahead and correct this and just leave it as a tag, run that inspect check again, it's going to tell me about my profile. It told me how many controls I have. It told me what time I did it at, and it told me that, hey, you have no errors or warnings. You're actually all set to go ahead and run this profile.
Woohoo, looks good. So now that you've created your first profile, now it's time to basically scan your machine. So inspec makes that really easy. The general command is inspec exec, and then your profile name, and then you can specify your target machine. And once you do that, it'll spit out some of the results.
So here I'm actually trying to get it up right now. Inspec exec profiles, and I'm just going to run it against a profile that I have already set up in my repo called simple SSH.
Nice. So here, this is basically everything that was tested here. It'll provide you with the expected state as well as the current setting on your system. And below, you can see that how many controls in your profile passed or failed, as well as the individual tests, which ones are passed, failed, or just genuinely skipped. Now, this output is really nice, but you can also do an inspec exec profile name -- format JSON to output a JSON. So if you want to either integrate this in some type of UI or anything like that, you'll have a fantastic JSON format. And then you can also do inspec exec profile name -- format JUnit to output an XML file. And the XML output is great to integrate with your Jenkins pipeline.
Right. So like she said, that makes it really nice and easy. When you combine that JSON and JUnit output with those impacts, you really get a full control of what's happening there with your inspec results, right? Now, inspec has some other little goodies it can do. We have a concept of attributes as well in inspec. So if we come over here and we look at our profiles, we're going to take down my first profile that we used as an example. And I've prepared a few profiles in the profiles directory over here. So we have one called simple SSH. That's the one we ran earlier, right, with all of our SSHD tests. Now we have another one in here called attributes. This attributes, if we go ahead and look at the controls, it is actually telling us that, hey, the princess user is going to be the attribute user, and the default is Bowser. The princess password is going to be the attribute of password, and we didn't actually give it a default there. But then we went ahead and said that our tests, we expect that actually the princess user should equal Princess Peach, and the princess password should equal Yoshi for life. It's Yoshi. So if we go ahead and look over here at our attributes file, we'll see that we set the user to Princess Peach and Yoshi for life. Those are different values than what we have in the controls file. But if we go ahead and run this profile with that attributes file, hold on just one second, then we're going to go ahead and see that the results are the same. So if I inspec exec, and we're going to come back through here. We're going to do the attributes because we're selecting profiles, attributes. And then I'm going to go ahead and copy that attributes file right into there. So I say -- attributes, give it the path to the attributes file. And when I do that, we're going to go ahead and see that, yeah, Princess Peach should equal Princess Peach, and Yoshi for life should equal Yoshi for life.
So within your organization, there's probably some type of standardization that you need to do. So with one team where it's a profile, maybe you want to streamline, what you're testing for across your organization. Maybe some of the controls don't apply to, different teams or different parts of your organization. So inspec does have this concept called profile inheritance. And basically, it allows you to inherit controls from other profiles without modifying the source control. And how you would do that is you can actually go back into the inspec.yaml file, and you can add a depends with the name and the path to the profile that you want to inherit some of the controls. And then you have one more step. You go back into the Ruby file, and then you can say, okay, include these controls, but skip some of them, as maybe they don't apply for your team. Or you can say require controls, which would just require the specific controls that are needed. And basically, that's how you would do that. I would say, talking to a few customers, this is best practice, especially when there's certain members in your organizations that you don't want them to modify or edit profiles or, change the impact on controls. That this wrapper profile is implementation is best bet.
right? It really allows you to really customize those profiles, right? Because there are some profiles already available out there in the world, this really allows us to kind of give it our own little spin. So you can see here we did an include controls on the My Linux profile. We skipped a couple. We changed the impact of one. And then we did require on a couple controls over from the DevSec SSH baseline profile. Now I can run this profile. It is actually, if we actually go over and look at the depends YAML there that we had seen in the inspect YAML, we were actually pulling these. Hold on one second. Okay, so we have here DevSec SSH baseline. Now this name only reference is going to default to the Chef supermarket, so it's going to go ahead and grab it from there. And then we over here specified My Linux profile, and then we gave it a GitHub address. I'm not currently hooked up to the internet right now, so when I run this profile, it won't be able to go ahead and grab those. So we're going to skip the little running of that profile. But what's great about these is that once you do go ahead and run those profiles, and it gives you just the controls that you want specified from all the different profiles, along with whatever other controls you want to stick into that file, there's actually another command that you can run, which is called inspect vendor. And what inspect vendor is going to do is it's going to go ahead and take everything that you specified in that profile and create a little vendor directory within that profile, as well as an inspect lock. So now you know that anybody that you hand this profile to is running the exact same thing you did. Because it's already got the inspect lock in there, you're locked down to those dependencies.
And now that you've locked down the dependencies, now you can share it with your friends, right? Because
exactly.
Friends share profiles naturally.
So what we can actually do to share it out is we can inspect archive. So we can inspect archive any profile that we have. So for example, if I inspect archive profiles, simple SSH, and then I just do a quick ls, I'm going to see that I now have a tar.gz file right there, right? So I can go ahead and send that to anybody I want, and they have that same profile in a tarball ready for them to use. All right, so from there, so now that we've already inherited the profiles and we've archived it, there's actually some great things that have also come out with Docker. If you remember that that we already specified, we can run these profiles with a Docker transport, a WinRM transport, or an SSH transport. We can also, of course, run these profiles locally, right? So there was actually a Docker resource that came out sometime back, right?
Yeah, I think so. And I heard containers are so cool right now.
They are. So what's great about this Docker resource is it's going to go ahead and test those Docker containers locally on your file, on your computer. So that can be really useful if, for example, you have a dev environment with lots of Docker containers that you're handing out to your whole group of devs, and you're saying, hey, we want to make sure that those containers are actually running and set up the way we want them to be, right? So what we can do is I've already got a profile up here that we are calling the Docker Love. So in my sweet Docker Love profile, I've got a described Docker containers. Its images should include Mario meets inspect. That's a Docker container that I had brought up a little bit ago. I'm also asking about some server and client versions. I'm asking all kinds of information about my Docker containers, and it's going to go ahead and report that back to me. Now, again, I'm going to run this locally because I'm testing my local container. I'm not trying to test some Docker container here and the settings on it. I'm trying to test that my machine has everything I expect it to with my Docker containers. So if I inspect exec, profiles, Docker Love, we're going to see here that it did work. And just to make sure, we said here, hey, the images should include Mario meets inspect. So if I did a Docker images right now, we would, and let me just grep that, we would actually see that Mario meets inspect is certainly there. And we've got it. So it went ahead and reported the same information there, except we don't have to run through the Docker PSA and try to parse through all of that content because inspect is doing it for us.
So all those resources are pretty cool. Now, let's show them how to create a custom resource. Since, again, inspect is based off of Ruby, it's this Ruby class that directly inherits from the inspect.resource and is called via the control.
Okay, so here we have our Mario resource. And like Hannah said, in that custom resource, that's going to go, our custom resource, we're actually going to build out into that libraries directory. So here in our little Mario resource, we said, hey, Mario resource, go ahead and inherit from the inspec resource so you can get all of its stuff. We initialized it with some args, and we said, hey, if the args are why so mean, it should be Bowser. So if we go ahead and look at the tests that we included in our controls directory, right above that libraries directory, we'll see that we said, describe Mario, why so mean, it should be Bowser. So we should now be able to run this profile. Again, I'm just going to run this locally because I'm not necessarily testing anything against a node right now. So if I run inspec exec profiles with the custom resource, we're going to see that it did go ahead and read that resource in automatically from the libraries directory, and it said, hey, yeah, Mario should be Bowser. Now, that's a really cool thing, right? We can do a custom resource. Here's the great thing about inspec. We can do a lot more with inspec because it's just some Ruby in these files, right? So we can actually use the power of Ruby to make our tests do whatever we kind of want with them. So if we take a quick look over here, we can see that we can do things like set, hey, A is going to be equal to this command right here, and then we're going to go ahead and loop over it and run it. Here we set my services is going to be equal to the content of this YAML and the params part of the content of this YAML. And then we can go ahead and loop over it and use it just like we would with any kind of Ruby in a file.
So that was a lot of information today, but good news is that there's public profiles that are available out on GitHub or Supermarket, which is Chef's repository for cookbooks and profiles. So some of the GitHub sites that we do recommend is, one of them is DevSec, which is maintained by some of the founders of InSpec that are now at Chef. And they have all the server hardening, not all of them, but a few of the server hardening profiles that you can use right away that have cryptographic requirements as well. And then also the InSpec GitHub that you should check out. You can also check out Supermarket. So if you go to Chef Supermarkets, Google that. We have some of the profiles on there, as well as some of the community profiles. And then we have our enterprise offering. Whoops. Oops. Oh. No, we're not done yet.
And so
I went back, but we have our enterprise offering that has CIS profiles for compliance that you can use right away. We're looking into extending that offering for our compliance profiles and our enterprise offering, starting with PCI, and those are readily maintained within our organization. So when we just showed you how to inspect exec, for target systems, but our enterprise really allows you to continuously test your infrastructure. So basically being able to take those standards, your profile, and then scan, all of your machines, whether you have hundreds of systems, thousands of systems, all at once without having to manually go into the command line. And then we generate a report out of the inspect results here, an aggregate report. So here's an example. Screen size, things are a little...
Excuse the screen size.
Yeah. But we could show you a better screenshot later. So there's an aggregate view of basically, how many tests were passed, what failed. For compliance, we have two different views, right? So we have, so which systems are not compliant with some of the settings that I've set. But from a security compliance officer point of view, we do have a control-centric view in terms of, which controls were implemented and which controls is my organization compliant to. Within that, we generate individual reports per node, so you can go ahead and drill down, see a similar result in terms of the command line, the expected state versus the settings that were set on your existing system. And then you can go ahead and export those results in JSON or CSV if you need to share that across your team or your compliance officer or your auditor. You can access all of our premium profiles, again, CIS, for now from the profile store. You can download them, you can modify them, you can upload your own, and then you can go ahead and use our new scanner where you can basically import nodes. And again, they don't have to be Chef nodes, they can be any nodes. And then select the profiles that you want to test against, and then set the reoccurrence, which we'll be adding soon. For large-scale organizations, quickly, this is our MVP here. So we will have the ability for you to import, thousands of nodes via CSV. So if you do have a CMDB within your organization, then you can go ahead and plop in that CSV. Another thing that we're actually working on is integration with AWS, Azure, Docker containers, as well as networking devices. So basically, you can configure all that information, add your tokens for your APIs, and then go ahead and scan any part of your infrastructure.
Yeah, and what's great about that scanner is that it's really just InSpec under the hood, right? We're just starting out a worker pool, and we're saying, hey, go ahead and take these jobs, worker pool, go ahead and send somebody over to exec that, give me back the results, and I'm done. It's a great way to just execute any kind of profiles you want against any of your nodes and really have that set up in a customizable way that you can set off at any second that you want.
Yes. So ultimately, with workflow, the ideal workflow, right, and this is kind of a marketing pitch, I guess, is we're emphasizing detect and correct. So basically detect, the problems within your infrastructure with InSpec, and then correct it with Chef, which, I'm sure people at our booth are happy to talk to you about.
Yeah. So with all that, what questions can we answer for you? Yes. I think a mic is coming over, so.
Okay. So when we are running the inspec shell or inspec exec, we are passing the password as the plain text.
I was in that case. I actually usually just use my key.
So, does it support reading from the environmental variables as well?
I do. Yes, it does actually support reading from environmental variables as well. I just kind of needed it to be. I just put it right there because it was easier for everyone to see how to connect in.
Okay. Okay. Thanks.
Hi. For testing infrastructure, we use tools like Kitchen. So could you please compare InSpec with Kitchen and what advantages we get using?
Yeah, so we actually have Kitchen InSpec. So you can actually use InSpec along with your kitchen environments, right? So if you actually use Kitchen InSpec to run, you'll be able to specify all the profiles and specify everything just like you would with Test Kitchen. You just are going to go ahead. I have this. Hold on. I have it over here. If you just specify the verifier to be InSpec, you're going to see that you can go ahead and specify whatever profiles you want in that YAML file where you specified the verifier as InSpec, and it's going to run them against your infrastructure just like you would if you were normally running Test Kitchen. If I know we only had 2 questions, so if we missed anybody, if anybody has more questions, please stop on by the booth. We've got Nathan there, we've got Anthony, we've got Matt, and we'll be there too, and we'd love to answer more of your questions or help you out with anything Chef InSpec Habitat.
Thank you.